Have you ever watched fireworks and wondered why they explode in different colors? Reds, blues, greens, purples. It may seem random, but it's actually a very predictable process. The colors come from chemistry, and more specifically, how metal ions react when they're heated to extreme temperatures. When a firework explodes in the sky, the temperatures inside can exceed 1,000 to 1,500 degrees Celsius, depending on the composition of the firework. At these temperatures, the metal ions inside don't just heat up, they undergo electron excitation. Every atom has electrons arranged in quantized levels, meaning electrons can't just sit anywhere. They can only exist at very specific distances from the nucleus. When heat energy is added, the electrons get excited and absorb this energy, which makes them jump to higher levels. This is called an excited state. But excited states are unstable, and so very quickly the electrons lower into their more stable ground states. And the energy they lose on the way down doesn't just disappear. It's released as electromagnetic radiation, and at these temperatures, that radiation falls in the visual light spectrum. That's what gives fireworks their color. The exact color depends on how large that drop is. A big drop will produce high energy and short wavelengths, which will fall in the blue and violet range of our visual light spectrum, whereas a small drop will produce low energy and longer wavelengths, which will fall in the red and orange section of our visual light spectrum. Here's the cool part. Different metal ions have different electron configurations, so their electrons fall different distances. That means that each metal produces its own characteristic wavelength of light, and thus its own color. Potassium produces a distinct violet-purple flame. Its electrons move between their 4p and 4s orbitals when they relax down from their excited state. That drop releases light around 400 and 430 nanometers, which sits at the edge near the violet region of our visual light spectrum. Lithium compounds produce a bright crimson red. Lithium's electron structure is simpler, so the main transition is from 2p to 2s. This produces a wavelength around 670 to 675 nanometers, which is in the deep red portion of the spectrum. Copper ions create blue-green or turquoise colors. Their electrons transition between their 4p and 4s orbitals, releasing energy that corresponds with 500 to 520 nanometers. This wavelength overlaps cyan and green, giving fireworks that cool, underwater blue look. In chemistry, we can identify elements by looking at their emission spectra, the specific wavelengths of light that they give off. So fireworks are basically a huge demonstration of this idea, and the next time you're watching a fireworks show, you're not just seeing explosions. You're seeing electrons jumping, falling, and releasing energy in real time. It's chemistry, lighting up the sky. Literally.